It won't work even if it is the primary beam. So, what is the solution? You can use this primary beam, but one of its disadvantages is that if I have a small field of view or a small organ, I can only work on a small area or a small organ that I can image with it. Its use is like being cheap, meaning its price is low. However, the problem is that you will have the area of the edges that is present. So, what will happen is that everything you have will be affected. Therefore, I can use it for something if I am working on it. Now, if I have something else called crossed, notice here that you are essentially removing from one direction, while in the crossed, it is as if you have combined the two and reversed them. The cross technique helps to eliminate scatter in 2 dimensions. If we assume this is the y direction and this is the x direction, scatter in the 2 dimensions is in one direction. Or let's assume this is the y direction, for example, and this is its x direction. This gives it certain specific uses, and it will not be at the same price as the primary beam. However, the issue is that when positioning is done very accurately and the field of view is defined very precisely, there is also an advantage in that, the grid ratio. When you compare, for example, a grid ratio of 6.1 gives you the same scatter reduction as if its grid ratio were equal to the linear or parallel grid ratio of 12.1. Therefore, its efficiency in scatter reduction is considered higher. Now the focus. The focus is that we will create a design where the strips are angled, here in the center of the center array. For me, the strips are arranged linearly and then angled on the left side and on the right side in this way. This helps more so that the primary beams or the radiation beams pass through and reach the imaging plate, allowing for the scanning of a large organ or imaging a large organ. What is the mechanism? What is happening? There is always a problem. What is the problem? The problem is that there will be an issue. What is it? The problem is that there is no movement. In reality, if the grid was previously stationary, as you can see now, if the grid does not move, as you see now, if the grid was previously stationary and did not move, as you see now, if the grid was previously stationary and did not move, as you see now, if the grid was previously stationary and did not move, as you see now, if the grid was previously stationary and did not move, as you see now, if the grid was previously stationary and did not move, as you see now, will this cause a problem? You will create a problem because you did not take an image of your organ. He told you that we will create a movable image, meaning it moves in such a way that the part that is during the exposure time will receive radiation while in motion. Therefore, you will encounter the problem that you will create. I always use this in low frequency. In low frequency, but when you see, for example, the items that contain a chest pack or the items that contain a mechanism or motor mechanics, the grid starts to move in the way we see to address this problem. However, when you look at digital imaging, you use a high frequency grid in digital imaging. What do you use? You use a high frequency grid. And your grid is already at that point, your number of strips is very high. So why not use a high frequency grid to improve the resolution and significantly reduce the scatter? It will enhance the resolution and greatly decrease the scatter. Improving resolution is extremely essential, but keep in mind that this will come at the expense of your dose, which you will find will increase. There are problems with every grid used, like the first grid. The first problem is what they call the shoulder grid. What does grid cutoff mean? This part refers to something that is not captured in your imaging or in your origin. This is called grid cutoff. So, you will have errors related to the grid, with errors resulting from the design, like the pattern, for example. There are also errors if you do not adhere to your video view and the SID, which indicates at what distance you should capture. Certain errors will start to appear, such as focus issues. For example, it should tell you that you need to work at a specific SID to ensure that the focus of the grid is the same as the focus or center line of the X-ray, which should be the same as the center of your grid. If there is a shift to the right or left in the grid, this will affect it, causing a cutoff or off-center artifact. Now let's take a look at this. I have 4 grid errors. One is called off-level, another is called off-center, another is called off-focus, and the last one is called upside down. So what is off-level, what is off-center, what is off-focus, and what is upside down? The off-level occurs when I am trying to get up from underneath. There is no problem. The upside down means that the grid itself is inverted. The grid itself is inverted. Here is the focus grid, and it flipped during the imaging process. What will happen is that the area that is supposed to be in the peripheral will have low intensity of radiation passing through here because you have flipped your grid upside down. So what will this do? You will find that the peripheral of your field of view appears like this. Why? Because no radiation reached the 2 areas, so it appears like this. So what is this? This is upside down. Now what else? The off-level. What does off-level mean? It means that the grid itself is tilted, or the X-ray tube itself is tilted in this way, so you have a side issue. There is a part of the peripheral that shows the image with this problem. There is an off issue, and there is an off-center where it moves itself. This means that the center of the X-ray beam is not the same as the center of the grid. Where is it? So, the image will appear with a problem like this. The entire accuracy of the child that is happening is that if it moves, then the center of it is not the same as the center of the grid. It's not the same as the center of the grid. This will also create an artifact that will result in a grid cutoff, and there will also be a part of your image in the briefly region where the radio back dynasty will appear. Now, if this is off-center, what about off-focus? Off-focus means that you need to work at a certain distance. At a certain distance, the grid must be at a specific distance. Why? Because the focus of the grid itself must align with your focus. So if you change this distance or adjust it in this way, the grid will start to show results, shape. These are the problems with the grid. There is something called the aliasing artifact. We were discussing the topic of the aliasing artifact, or the moire pattern. And we can assume that it deals with the dynamic grid.
Center dot. What will it be common with? Isn't that right? I mean, when you think about it, everything we've discussed so far points to this conclusion, doesn't it? It's quite clear when you consider all the evidence and the facts that have been presented.
Are you asking if this happens in dynamic imaging? Does this happen to me or not? No. The situation here is different. There has been a shift in the grid itself. This is what I am talking about. Focusing only on the grid. The grid itself has shifted, so the design of the imaging has changed. Do you understand? If you are getting your view, this is different. And then you move, for example, burning my name in. All right, so should I continue? Okay. The pattern that appears here, which we also have in this form, is related to the cervical, or in the case of the skull. This is the pattern that has appeared in this way. This is a type of grid artifact. So why does it appear like this? Why do you have artifacts appearing in this form? Why? Why did it appear like this? The reason is that the fixed grid in the rest did not move because your motion mechanics did not operate. Therefore, the parts that fell or dropped onto your components, if they move, there will be a chance for this part to be captured or reach a signal on the imaging plate. If it doesn't reach, it will appear to me in this way. There is another thing called assistance between the grid itself and the detector present. What does this mean? I said that I have different differences in the grid. There are higher differences and lower differences. If I were now, for example, in digital imaging, I use a fixed grid, but in contrast, the part that doesn't move here is compensated by designing it to be high frequency. What does high frequency mean? For example, if I have two objects like this, these are the strips related to the grid. The idea is that the strips here act like a collimator, improving your resolution. How does this work? It tells you that, for example, this gap allows the two signals to pass from the two objects, and the distance between them is very close, but the gap is large because you are using a low-frequency grid. A low-frequency grid means that the number of strips per centimeter is low, resulting in a large gap. In this case, the signal that comes here will be an averaging between the two signals. Therefore, the discrimination or resolution of your signal will be weak. In this case, the intensity here will be averaging, which translates to you being unable to perform discrimination, or this appears in your image as if it has a lens, or as if there are lines present or signals taken in this part or region. We refer to it as hypo-hypodensity in this way because it is not capturing the bright intensity signal. It is as if it is averaging between this signal and the adjacent signal. So, what is the solution? The solution is to enlarge. Increasing the number of strips per cm means providing better discrimination and improving resolution, which will help in reducing the aliasing artifacts that may occur in your image. This is why high frequency is used in digital imaging, as it allows you to differentiate or remove the aliasing artifacts that can occur in your image. The same idea we were discussing is that a large number of pixels can be risky when it comes to defining images. This also gives it more definition. The grid here also helps improve the definition, especially with the fixed grid in digital imaging, and it removes the aliasing artifacts.
I don't know how the videos will be enhanced, because if I increase the number of lid strips, photons from one device will gather while another will pass by. So I won't see the devices among those devices, because it will improve how the videos are increased. The nice idea is that we can increase the number of pixels or number of detectors because they are fine.
If I increase the lid strips, that makes sense. But how will I increase the lid strips to improve the lid strips? Great. If I increase the lid strips, it means I have increased the frequency, right? Okay. The frequency depends on what? It depends on the thickness of the existing lid strips and the gap that exists. This means that the lid strip itself has a thickness. Now, in order to increase the number of lid strips, what do I need to do? I need to reduce the gap and reduce the thickness. So, what will reducing the thickness do? It will make it the beam you have, or the X-ray beam you have, that is currently being used, should consistently remain visible on the image or on the screen. If you reduce thickness and gap, 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 if you reduce thickness and gap. Well, you asked. What? I said, well, right now, okay. If I have here. So here is a strip and there is a strip. For example, it exists, right? The movement tells me that if there are many strips, what will happen? The number of strips will increase the chance of photons falling on the strips themselves, right? Okay, will the number of gaps increase or decrease? It will decrease. No, slowly, I increase the number of strips, so the number of gaps will increase. Great. The number of gaps will increase when the gap increases, meaning each gap will be responsible for a specific object, right? Right, that's correct. So now it has decreased, reduced price.